Welcome to lecture series on design and analysis of algorithm. In today's lecture series, we will discuss about the working of Prim's algorithm. In the earlier lectures, we have seen what is a spanning tree. Earlier lectures, we have seen initially what is a graph, what is a spanning tree, what is a minimum spanning tree, and what is the approach used for constructing a minimum spanning tree, which is greedy technique. We have seen the explanation of what is greedy technique and what are the problems that can be solved using greedy technique. We have also seen the difference between divide and conquer technique and dynamic programming. And in the previous lecture, I have explained how to construct a minimum spanning tree using Kruskal algorithm. There is one more algorithm which is used for constructing a minimum spanning tree, which is Prim's algorithm. As we have seen earlier, irrespective of the algorithm that you are using, the final outcome will be the same. That is, the final minimum spanning tree will be the same for a given graph, either if you apply Prim's algorithm or Kruskal algorithm. So let me give a quick recap on how this Kruskal algorithm works in finding the minimum spanning tree. So these are the basic steps followed in finding minimum spanning tree using Kruskal algorithm. Initially, you will sort all the edges in ascending order of cost. Next, you will start including the edges. So as you include the edge, you will make sure that inclusion of that particular edge will not form a cycle. So if in case it forms a cycle, you will discard that edge. So this step is continued until all the vertices are connected or until n-1 edges are present in a given spanning tree. So this is a working of Kruskal algorithm. Now let me explain about the working of Prim's algorithm. So let me take the same example we have seen earlier. So let us start from the vertex A. Now what are the adjacent vertices of A? We have two adjacent vertices B and F. So of these two adjacent vertices, which one has a minimum cost? F. So you will include the H from A to F. So next, the vertex that you need to visit is F. So what are the unvisited vertices that are connected to A and F? So the unvisited vertices connected to A and F are B and E. So of B and E, which one has minimum cost? From F to E, we have the minimum cost. So you will include that. Now A is visited, F is also visited. Next, the vertex that you want to visit is E. So now you have to find unvisited connected vertices of A, F, and E. So what are they? It is B, C, and D. So what is the minimum cost here? From A to B, we have 6. From B to E, we have 5. From E to C, we have 8. And from E to D, we have one of these 4 edge costs. E to D has a minimum cost. So you will include that edge. So you see here. So initially you have included A to F, then F to E, and E to D. These 3 edges are included now. Now, what is the remaining vertices that are connected and left unvisited is B and C. So what is the minimum cost? We have 6, 5, and 8. So inclusion of 6 and 5 will form a cycle. So you will not include that edge. So the only possibility is including an edge from E to C or from D to C. Both has a same cost. So you can include the edge from E to. So before that we have another minimum cost, right? So from F to B we have minimum cost 4. So that one is included. So in first edge that is included is A to F. Next F to E it is included. Next E to D is included. And fourth vertex that is fourth edge that is included is FB. At last we have remaining edges like 6, 5, 8 and 8. Of these 3, inclusion of 6 and 5 will form a cycle. So those edges are discarded. And then you will include the edge 8. That is from E to C. So inclusion of any other, this is how Prim's algorithm works. So every time you visit a vertex, you will find the adjacent vertex to it, adjacent connected vertex to it, vertices to it, and you will include the vertex that has the minimum edge cost. So if inclusion of that edge forms a cycle, that particular edge will be discarded. So this is how a Prim's algorithm works. So as you have seen, the working of Prim's algorithm is almost similar to the Dijkstra's algorithm, which we have discussed when talking about finding shortest path. So here is another example for you to have better understanding on constructing a minimum spanning tree using Prim's and Kruskal algorithm. So let me summarize what we have seen in all the three lecture videos. So initially we have seen what is dynamic programming approach, what is greedy technique. Then we have seen what is a spanning tree and what is minimum spanning tree. So a spanning tree is nothing but a subgraph of a given connected graph. It includes all the vertices, and it is a tree without any cycle. And the properties of spanning tree are, if there are n vertices, and they obviously there will be n minus 1 edges, and spanning tree may not be unique for a given graph. We have also seen what is minimum spanning tree. So the spanning tree with minimum total cost is minimum spanning tree, and it can be applicable only to a weighted connected graph. A spanning tree can be constructed only for a connected graph. However, minimum spanning tree can be constructed only for a weighted connected graph. So algorithm used for identifying minimum spanning tree is Prim's and Kruskal algorithm. So it is mainly used in establishing the network, and it is also used in clustering algorithms when we talk about machine learning. So there also minimum spanning tree is applied. So hope you understood what is greedy technique, why a greedy technique is used for constructing a minimum spanning tree, and the algorithms, which is Prim's and Kruskal algorithm, used for constructing a minimum spanning tree as well. So thanks for watching. We will discuss some other interesting topic in DA in the next upcoming lecture series.